we'll kind of skip through some of these a little bit so we can get things moving. This is a back plate that's cut off on one of our 4-port splitters, and you can kind of see we've got, this would be the input here, and then output, 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 and output. And if you notice, the center conductor right here is soldered directly to the blocking cap. It's not soldered to the board, which I'll show you some competitor samples in a minute. The reason we did that was to prevent any sort of, we didn't want any forces on that solder joint, because when you solder directly to the board and you solder the board directly to the housing, it's very rigid. And with thermal fluctuations and mechanical, if you drop a splitter when it's freezing cold, you have a really high probability of cracking a solder joint and then ruining performance. So if you'll notice, we screw the board down. We also solder the board down. We've got a screw on either side. We solder here, and we solder in these 2 locations as well. So we've got room for flexibility, and then we also take that center conductor and solder it right to one leg of that capacitor. So you've got plenty of room for fluctuation, and you don't have to worry about a cracked solder joint or a cracked board. Now here's an example of a signal vision splitter, and you can see how they're basically relying on this glob of solder to make that connection. I mean, it's not even lined up with a PCB. It's just a really poor way of going about it. These here are PCT splitters, and you can just see this is all flux, leftover flux. This here is a solder ball that was not heated to the proper temperature. Same thing over here. Sloppy solder here on the ferrite. Just a real poor job. The quality and consistency is just not nearly as good as what you'll find with the Evolution splitters. This here, the wire diameter, this has no effect on our performance whatsoever. This is Signal Vision, competitor C here. They're the only ones that use a thinner wire diameter, and this is for the ferrite windings. What I've noticed is we've done splitter failure analysis for a number of customers, and the biggest problem with Signal Vision and these wires is actually during the manufacturing process. They'll say they get these out of box or out of the bag, and they plug them in, they don't work, and they ask us to find out why. And these wires are broken because they're so thin that the soldering iron will actually break them in the manufacturing process. And if they did 100% QC, they would find that out before they ship them, but to our advantage, they ship them out anyway. So this here is an example of the seizure mechanism that we use. This same seizure mechanism is used not only in the splitters and directional couplers, but also the amplifiers and the entry device. So we're consistent across the board, with the one exception on the vertical splitters. It's a shortened type of seizure mechanism. It's I wouldn't say it's conical, but it's not duckbill either. I'll have to show a picture to you guys when we do the regional trainings. But this is used throughout the product line. Sealed F-ports. This is another critical thing. You don't want any moisture migration, and everyone requires at least 15 psi of pressure to seal all the ports. And if you notice on our splitter here, it's completely sealed visibly, whereas on these other 2, it looks, you can't even tell if there's anything in there. And actually on competitor A here, you can blow right into the port and blow air out any of the other ports. The way ours is done too is not with an epoxy or a silicone or anything. It's the port itself is slightly V'd at the bottom, and so when that dielectric, that blue stuff right here, when that is shoved in there, it forms a tight weather seal. So you're not relying on someone to actually put an epoxy or silicone or anything in there. That's just part of the manufacturing process. Are there any questions on the splitter lines? That's it for now until we go into a deeper dive.
I got a question. This is Dane Houston.
Yes.
What's the RFI protection or port-to-port isolation on? I didn't see specs on that.
The RFI, the splitters will do, I believe, in excess of 130. I think we've almost hit the noise floor of the GTIM over there. Mike Lawrence has done testing for us on those for Comcast and Time Warner. And they exceed, I believe, 130 across the board. And port-to-port isolation, we guarantee this is one of the things we have to go through with the MSOs is, what's your bare minimum, what's your typical. Our bare minimum is all the SCTE requirements for isolation, and there's basically 4 different frequencies within the 5 to 1,002 megahertz range, and we exceed those across the board.
Okay.
Yes, Alan Amato with a question.
Yes.
I noticed that you had the CUL logo on the splitter. Does that mean that you can use it for CSA in Canada?
For CSA, that's a good question. I'm not quite sure. I know that is the Canadian UL listing to have the C up there, but as far as CSA, I will have to look into that.
Canadian listing is what I mean. You could sell it in there at the equivalent to CSA. Do you believe that?
Oh, okay. Yeah, I see what you're saying. Yeah, we actually just got approved at Rogers with these up in Canada.
Perfect.
Yes.
Chad, this is Rick Hobby. Is there any other Senelec approval required for Europe or South America or Asia?
Rick, I honestly don't know. We were focused 100% on North America, so the U.S. and Canada, and honestly did not explore any of the other countries. So that's something we probably need to look into.
Right. Okay.
Any other questions? If not, we'll move on to the amplifiers. This one's a little bit quicker. There's a picture of the 1-port and 4-port drop amplifiers. I'm not sure how many of you have sold drop amplifiers before, but when you say the number of ports, it typically refers to the number of outputs. So on this 1-port amplifier here, you have an input, your primary power port, and then your output port, which can also be used to power the amplifier. All the ports are facing down on this unit. The two-way is also, all the ports are facing down on it. The two-way looks just like this 4-port amplifier, but these 2 top ports are not present. Here's a model numbering scheme once again. All the drop amplifiers that we currently have in production are active in the forward path, which means that they have an IC chip in the forward and they provide gain from 54 megahertz to 1,002 megahertz. But the return path from 5 to 42 megahertz is passive. So depending on the number of splits, that depends on what the return path loss is, and it also affects what the gain in the forward path is. So if you look on this page here and we say that it's a 1-port 15 dB forward passive return, that means whatever signal level you have at the input port, it's going to be amplified 15 decibels at the output port. And going in the return path in the upstream, you'll have, I think on the 1-port, approximately 1.5 dB of loss. When you go to a 2-port, it's going to reduce that 15 dB gain by 3.5 dBs. So on a 2-port, you're looking at a forward gain of about 11.5 dBs, a 4-port about 7, and an 8-port about 4.